pollution from roadways, but it's also non-point source pollution, meaning not a direct input to the lake. And this comes from these areas we call the wildland-urban interface, or where South Lake Tahoe is and the forest. The edges tend to pollute a lot more. They're disturbed. And so we've done some studies where we look at nutrient pollution around the lake in different watersheds. You're here, okay? For orientation, you were here yesterday. Oh, here yesterday. And here, in Incline at the center. And we basically find that the most pollution comes from these areas with not just urban areas, but urban and watershed forest interaction. All those sediments and nutrients and algae are coming into the lake. This is the 1960s with very little algae. We used to grow lots of algae to the bottom, down to 105 meters. But now, with more algae growth and more sediments, today, we actually restrict the light that hits the bottom, and you're changing the bottom ecology of the lake now. There's not as much algae to 100 meters, it's mostly to 40 meters below the surface. That means all of these organisms are actually starting to change at the bottom. I'm going to talk about those. So the change in the watershed doesn't just change the open water, phytoplankton, it changes the structure of the bottom of the lake.
I have a question. You said that the ratio for the demand of nitrogen and phosphorus has changed between the 60s and the 80s. This has changed because the types of algae has changed, or what caused that?
No, it's because that's a very good question if I didn't make it clear. It's because globally, you're driving cars, you're putting fertilizers on your crops, and locally, we put nitrogen into the atmosphere, a lot of nitrogen. It's a greenhouse gas also, we don't talk about it. So whatever we're doing globally, we're adding more nitrogen to our soil to make more agricultural crops. We're driving our cars more, which makes more nitrogen pollution. In this case, local pollution of cutting wood and burning it produces more nitrogen.
Okay, let me...
So that nitrogen is in the atmosphere and it deposits into the lake.
Okay. That was not my question. Let me make myself a little bit more clear. I know that the ratios has changed inside the lake. It was more nitrogen in the 60s and up to the 80s. Now there is more phosphorus, and we know because of the pollution. But you were saying the needs for the growth of the algae has changed. So I'm stressing on the word needs.
Yeah, the need has changed because the ratio of need has changed. I don't know if this makes sense. You put more pollution in with nitrogen. The algae used to want nitrogen.
Yeah.
Now they're like, because of the pollution, they're like, I love it. They look up, they get lots of nitrogen every day. Even our driving our cars today. It looks clear outside, but there's a lot of nitrogen coming in from the atmosphere. And now they no longer need the nitrogen for supply, they need the phosphorus. So their need isn't because of the change of the type of algae, it's literally because of the supply.
Nitrogen.
The supply. So I always think about it this way. Who likes cookies? Come on, I saw you guys eat cookies yesterday. Okay. Who likes milk? Okay. If you eat one cookie, do you need one full glass of milk to wash it down?
No.
No, maybe a little less, although some of you love milk. So if you eat 16 cookies, 16 nitrogens, then do you need a full glass of milk to wash it down? More milk, maybe more milk, right? Yeah. You at least need that glass of milk. And the milk represents phosphorus. The cookies represent nitrogen. So as soon as you start adding more cookies into your diet, nitrogen, you're going to want milk to grow. And so but the cookies and milk have not changed. The human has not changed.
Okay.
What's the main source of energy here at Tahoe? Source of energy, electricity.
Oh, yeah. No, power in Tahoe, I mean, it's a whole conversation in itself, but the regional power system of the United States is all gridded. So it's not local. It's based on... No, I mean, we have geothermal in Nevada, then there's a mix now of geothermal and then hydro in California mixed with coal is still there, but a lot of natural gas burning. So for us, the local power here isn't just demanded from natural gas in California, although that does come up. California's energy demand has shifted a lot to geothermal from southern Nevada and solar. And the grids are actually moving energy into California during shortages, especially in the summertime. Yeah.
And has that changed the level of pollution drastically?
Yeah, so that's an interesting question. So the U.S. policy has been, for the most part, until the last administration, to remove off of coal, and that's changed the level of atmospheric pollution on nitrogen, but a lot of mercury deposition. So we have seen regional changes in 25 years on the decrease of mercury in water here. Not just at Tahoe, but the region. Yeah. Yeah, I mean, there's no doubt, and and I shouldn't even just say that. I should say the 1970s plans to control atmospheric sources of pollution also reduce the acidity of water. So water can be acidic or basic, and especially not here, but in the northeast and central part of the United States, the lakes and rivers have actually gone back to average in Canada than before the pollution started, because there's a lot of pollution control on combustion and filtration. Okay, so I want you to just take home this story. What happens to the center of the lake, like we learned yesterday, is definitely affecting the deep bottom of this lake. And the deep bottom of lakes are important because the bottom of a lake is more like your heart. It's actually has a lot of bacteria, has a lot of plants. It tends to be the long-term processor of the lake. So you don't want to mess with the bottom. So at the bottom of the lake, let me see if I can switch this over. Here's some divers we sent to 50 meters or so. At the bottom of the lake, these are our divers going down to deep water, and we're collecting plants. The plants are about this high, not too high, historically, but there were plants everywhere around the lake, all locations. And these plants are really important for photosynthesis, to sequester carbon and nutrients. But they're also very important home for little fishes and invertebrates. You'll see one swimming around up top. There's another one. And little invertebrate stoneflies and amphipods. I'll talk about them in a second. So this is fun work by our lab because we tend to use divers to go down. So I call these sensitive plants. These plants used to live in the deep bottom. Used to live in the deep bottom at 120 meters to 500 feet, maybe 40 meters to 150 meters below the surface. But today, we've seen the plants disappear because of changes, just little changes in the clarity. Here's depth, shallow water on the left, deep water on the right. Here's the number of plants we used to see in the 60s in dark black. And today, we only see them down to 90 meters. So whatever you do to the open water with algae pollution and with nutrients, completely reshapes the bottom of the lake. And why do I care about this? Well, I care about it because plants are key for life on the planet, not only producing oxygen, but in this case, habitat for fisheries and for my invertebrates. And today, we send divers all around the lake to do surveys. It took us a year. And we only have about 4.5 acres of plants left. West Shore, outside of Emerald Bay, South Lake Tahoe, and here and here. So these plants are disappearing more quickly than the phytoplankton are growing in the open water. Why is it occurring? Well, sunlight. More algae, less sun goes to the bottom. You're now seeing changes in the flows of energy to invertebrates. And we've had a 10-fold decline in the native fish here. Remember the fish you saw yesterday?
Yes.
In the 60s, we had 10 times more fish, and today we see 10 times less. The biology is definitely changing with just a little bit change in clarity. The lake is still blue, but not as blue as it used to be. It's changing my little invertebrates. Here's a photo of one of my favorite invertebrates. It's the size of a quarter. You know, a U.S. quarter? I have one. Anyway, a little bit of change. And it's a stonefly. Stoneflies traditionally are significant because they live in high water quality areas. This stonefly is very special. It actually gives live birth. It's one of the few species on the planet, other than at Lake Baikal in Russia, that gives live birth. Very unique. The mom usually has 20 eggs after 3 or 4 years of growth. So it takes 3 or 4 years for the mom to grow for a reproductive cycle. Only 20 eggs. And it gives live birth, unlike the other taxa. Here's a beautiful kind of photographs that my students took. Here's the mom. Just look and see it packed with eggs, growing on the plants at 50 meters.
What do you mean by the live birth?
Live birth means, so sometimes when invertebrates, they'll lay eggs on a plant, and then those eggs hatch, and then they grow. In this case, the mom is producing her young inside of her and releasing it. And this is unique for this stonefly, because the only other stonefly that does this is in Russia, in the deep water lake. Only 2 places on the planet. Yeah. Do you have questions?
Yep, question. From yesterday up to today, we've been talking about watershed, water in general.